All right, good evening, students. It's Ask Mr. Rich Q&A. That is Sunday night, the 23rd of February. I've got a few questions here that we're going to tackle. We're going to do some geometry. We haven't done geometry in quite a while. So if you're watching this, then maybe the geometry will help you because you can always use geometry for your ACT and SAT, if for nothing else. And most students getting ready for the ACT could use some help with triangles and geometry. So let's take a look at what we got. I will share my screen, and this is it. I've got Desmos open up over here if we need it, and I've got a TI-84 graphing calculator. So we're going to start with number 3 here. So this says to show evidence of complete and corrected solutions. Show all work, SPP. Okay, I'm not sure what that means. Number 3, when a 5-foot vertical pole casts a 3-foot 4-inch shadow, a palm tree casts a 20-foot shadow. Find the height of the palm tree. Well, this is probably having to do with about similar triangles. So they're giving us 2 scenarios here. We'll draw them. So the sun is in a position such that if you had a 5-foot vertical pole right here, it's going to cast a 3-foot 4-inch shadow. So the sun is shining and it casts a shadow that is going to come down right here. And the length of that shadow is 3 feet 4 inches. So I got a couple options here. I need to get everything into either feet or inches. So I'm going to get it in terms of feet. So I know that 4 inches is 4/12 of a foot. Over here, my calculator, let's just do 4 divided by, it's 0.3, it's 4 1/3, 3. So this is 3 feet and 1/3. 3 1/3 feet would be 3 feet 4 inches. But then there's another situation where there's a palm tree that's in the same sunlight. We don't know its height, h, but we do know that it is going to cast a 20-foot shadow down here. And so since presumably these 2 objects, the pole and the palm tree, are facing the same sunlight, it would mean that these angles would be congruent, that these triangles are what we call similar triangles, that their corresponding angles are all congruent. And that, of course, we're assuming these are totally perpendicular poles and palm trees. So what we do is we're going to make then what we call a proportion, because the sides of similar triangles are proportional. So we'll say 5 feet is to h feet, right? I'm taking this proportion, 5 is to h, as 3 1/3 is to 20. Now I'm going to write this 3 1/3 as 10/3, converting it to 10/3, and that's to 20. So now what I'm going to do is I'm going to cross multiply. If I ever am running into an equation where it's 2 fractions equal to each other, I know that their cross multiples have to be the same. 10/3 times h must be equal to 100, 5 times 20. Then to solve for h, I would multiply both sides by 3/10 to get rid of the 10/3. 3/10 times 10/3 is 1. So the h is 30, right? That's going to be 300 over 10, which is 30. So that means this palm tree is 30 feet tall. Okay, Macklin, that's what's shaking there. Okay, next. Again, if you're just joining us, if you have any homework questions you want me to work, text them to me. Don't text them to me. Email them to me at askmrrich@gmail.com. I just sent it again in the chat for those of you that just came in. You can take a picture and email it to that email address. And then I've got the email address open and I'm looking at the inbox and nothing new has come in. Whoa, maybe a few things came in. Let's see. No, but I'm not in the right inbox. Now I am. Sheridan, thank you for sending some stuff over. We will take a look at that. I'm going to do one more of these geometry problems and then we'll do some algebra too. I hope you're not being too tough on me there, giving me the hard ones. They look like, I don't know, I can't really see them from here. Here is number 14. This says here on 14, it gives me 2 triangles and it says that triangle RST, this little squiggle, or I think it's called a tilde, that's what that is. It means similar to. So this says triangle RST is similar to triangle UVW. Find the measure of angle W. Well, one thing that I know is that W, its angle has to correspond to angle T, because when you see these similarity statements, the relative positions of the names of the triangles are important. That means that those are the congruent angles. I know angle R is congruent to angle U, S is congruent to V, and T congruent to W. So when I look at this picture, it looks like, whoa, looks like we got cut off right here. I'm missing some information. But what we can do is, since we know U is congruent to R, then we could write this. I'm going to put it up here. 3x has to be equal to 10y minus 2. All right. And then, Macklin, can you type that in there? What is that supposed to be right there on 14? What's the term missing for angle T? Type it over there in the chat, if you would, please. Oh, okay, while he's doing that, Sheridan, I am going to pull up your. This looks like ACT stuff. Maybe. I don't know. Let's take a look. Here is the questions from Sheridan. All right, hopefully you heard me there, Macklin. I'm missing some information on that. I need to know what angle T is. There's a missing term there. This is a couple of questions here. So this says, if theta is between 0 and pi over 2. Is this from you, Sheridan? Yes, it is. Sheridan, where'd you get these questions from? Type it in chat. If theta is between 0 and pi over 2, which following is equivalent to this? Well, what they expect you to do here is to recognize that there is a trigonometric identity. Sine squared theta plus cosine squared theta is equal to 1. So therefore, this 1 minus sine squared, they expect you to recognize that that is 47. Okay, thanks. From your math teacher. Okay. Well, I just wondered if they were, because is this from your geometry? This is not from your algebra 2. Got to be from something else, but I guess you're getting ready for a test maybe in something other than algebra 2. But since sine squared plus cosine squared is 1, it means that 1 minus cosine squared theta, sorry, I'm going to do this right here. 1 minus sine squared theta is equal to cosine squared theta, right? If you move this sine squared over to the other side, subtract it on both sides, you get cosine squared is 1 minus sine squared. So this expression right here can be rewritten as cosine theta over the square root of cosine squared theta. And then when I take the square root of squared, I'm going to get cosine theta over plus or minus cosine theta. Okay, so now if it's in the first quadrant, then so our answer could be either 1 or -1. But if it's in the first quadrant, cosine, yeah, if it's in the first, because that's what this means here, between 0 and pi over 2. So between 0 and 90, then this has to be a +1. Although it looks like it's a little unclear that it could be 1 or -1, but I'm going to go with 1 on this. Okay. But that was the key, knowing this trig identity right there. Number 30, given that I is equal to the square root of -1, which the following is equivalent to 2i times I to the third minus 4i? Well, I'm going to distribute the 2i. So that gives me 2i to the fourth minus 8i to the second. What they want you to know here, Sheridan, is that since I is equal to the square root of -1, I squared is -1. I to the third is -I, and I to the fourth is equal to the number 1. This is the progression that you should know when it comes to the powers of I, and then they start over again. When you get to I to the fifth, that's the same as I, because I to the fifth is I to the fourth times I, and I to the fourth is 1. So it starts I to the sixth would be -1, I to the seventh, I to the eighth, up 1. So just making those substitutions, 2i to the fourth is 2. So coming down here, that is 2, but I squared is -1. So that would be -8 times -1 or +8. And that's your answer 10 right there. Macklin says that that's a plus 47 that we were missing. 9y plus 47. And I believe him. All right, that being the case, what else could we do here? This would mean if that's 5x plus y, then this is 5x plus y because everything here is congruent, which would mean that this is 9y plus 47 also. Okay, so then what could we do here? I think we're going to do this as a system of equations. Did they give us any other information here? No, that's it. Okay. So what do we know? We know that 10y minus 2 is equal to 3x because these two angles, U and R, have to be congruent. So I can establish that relationship between x and y. The other relationship that I could establish is that I guess I could sum up three of these and set them equal to 180. I think that's the only other relationship that seems obvious to me is that if I added, and I'll use these guys over here, if I add all three of those angles, I get 3x plus 5x is 8x. There is a 9y and a 1y. That would be positive 10y. There is a plus 47. And the sum of those three angles must be 180. So it looks like that's what I'm going to do. I think so. And look at the substitution. That looks like it's going to be pretty easy. If I take this equation here, Macklin, and solve it for 10y, 10y is 3x plus 2. I'm going to take 3x plus 2 and stick it into the 10y here. So that gives me 8x plus 3x plus 2 plus 47 equals 180. This is 11x plus 49 equals 180. I'm going to subtract the 49, which would give me 131. I don't like that. Is that right? 180 minus 49? Yeah, 131. All right, let's make sure we got this right. 10y minus 2, since u is congruent to r, it is. 10y minus 2 is 3x, so 10y is 3x plus 2. 8x, 5x and 3x. 9y and 1y is 10y, and then 47 is 180. All right, we got somebody else joining us here. All right. Anyways, I'm doubtful of your 47 there, Macklin, because now that didn't give me an x value that was an integer, which doesn't really make sense to me. And let's make sure 3x, 8x, 3x plus 2. 10y is 3x plus 2. Yeah, I have my doubts about that 47 there, Macklin, but because I didn't get a whole number when I solved this for x. So check that and see if that's right, because I have a hard time believing that would involve fraction answers there for the measure of angle W. All right, I'm going to pull up another one that was sent in by Sheridan. So you see the strategy there? If it doesn't work out, I just blame the student. Is that what your teachers do? I hope not. Anyway, okay, so this is 18. In the accompanying diagram, CB is 12. That's already marked. AB is 13. That's marked on the triangle. And C is 90. That's marked as well. Cosine of A. Well, cosine of A, here's my angle A right here. What you have to know is SOHCAHTOA. If you're going into a standardized test like an ACT or an SAT, or you're going to be asked about anything with trigonometry, you got to know the three trig functions and the ratios that they all represent. And SOHCAHTOA helps you with that. So the CAH, that's the cosine. This tells me that when I take the cosine of some angle theta, it is a ratio of the adjacent side to the hypotenuse. That's what the A and the H of Ka, of the SOHCAHTOA, stands for. Relative to angle A, the opposite side, the adjacent side is missing over here. But I do know the hypotenuse is 13. But if you do Pythagorean theorem, you would find out that this is a 5 right here. Or just simply know that one of the right triangles that you should have memorized is the 5, 12, 13 triangle. If I did the Pythagorean theorem, 13 squared is 169. I would take away 12 squared, which is 144. I get 25. And then when I square root 25, that gives me that other side 5. So yeah, cosine of theta will be the adjacent side 5 over the hypotenuse 13. So remember, which side is adjacent and which side is opposite depends on which angle you're talking about. Because if I'm talking about cosine of angle B, then 12 is the adjacent side and the 5 would be the opposite side. Okay, hope that helps. Macklin, did you check that 47? Double check that thing because I have my doubts. All right, let's see if anything else came in. Yay, Grace sent some stuff. Ooh, I like this. This is Algebra 2. Let's see. Grace's problems are the last ones besides Macklin's problems. So if you got something, send it in to askmrrich@gmail.com. Here is Grace's problems. These are all, well, the first two are exponential equations that have to be solved. Well, what I'm going to do here is I'm trying to solve for n. So the first thing I need to do is get rid of the negative 2/3 exponent. So what I'm going to do is I'm going to raise to a power on both sides to get rid of that exponent. And the power that I'm going to raise to is the reciprocal or the flip of that negative 2/3. So I am going to raise to the negative 3/2 power. Because when you raise powers to powers, you multiply those exponents. So negative 2/3 times negative 3/2 is just positive 1. So that frees up this 3n minus 1 because it's now just to the 1 power. And so now it has no more exponent. Over here, though, I had to do the same thing to the other side. I have 1/4 raised to the negative 3/2 power. All right, so what do I need to do? Presumably, you are not going to have a calculator, and you need to come up with what 1/4 to the negative 3/2 power. And that might seem like a daunting task as to what in the world does that mean? Because I cannot proceed with my algebra until I go ahead and figure out what that number is right there. So the first thing that I'm going to do is I'm going to use my negative exponent rule. My negative exponent rule says that if I have something in parentheses that's raised to a negative power, I can take what's in the parentheses and flip it and then change the sign on the exponent. So I'm going to do just that. I'm going to make this a 4/1 or just 4 and change that to a 3/2 power. That gets me a lot closer. Now I'm going to show you the long way and the short way to understand what 4 to the 3/2 power is. Here's the long way, or probably how your teacher would tell you to do it. I'm going to take 4 to the 1/2 and then I'm going to raise it to the 3rd power. In other words, I'm breaking this 3/2 up into 3 times 1/2 because 3 times 1/2 is 3/2. That means I can apply the 1/2 power first and then apply the 3 after that, because when you raise powers to powers, you do multiply exponents. So this is equivalent. The way I've set this up, it's equivalent to 4 to the 3/2. Well, you also need to know, though, that raising 4 to the 1/2 is the same as taking its square root. The square root of 4 is 2. And then 2 to the 3rd power is 8. So as it turns out, 4 to the 3/2 is the number 8. I'll show you the shorter way that you want to think about those fractional exponents in just a minute. But now that I know that 4 to the 3/2 is 8, I can add 1 and divide by 3. And Grace, that's going to be my answer to that equation. N is equal to 3. Now, here's how I do these exponents. If you're ever given on a standardized test or one of your summatives, you're given a fractional exponent and you have no calculator, they're going to make it so that it can be figured out. The way you do it is know that the denominator of your fractional exponent is the root. So that's the second root, or called the square root. So you apply the root first. The square root of 4 is 2. Then once you get that answer, 2 in this case, you raise it to the numerator power, 8. Square root of 2 is 4. Excuse me. Square root of 4 is 2. 2 to the 3rd is 8. So I know that this is 8. Some other examples. 64 to the 2/3 power. Well, I'm going to apply the 3rd root to 64. The 3rd root of 64, hopefully you know this, is the number 4, because 4 to the 3rd is 64. So the 3rd root of 64 is 4. 4 to the 2nd, boom, done, 16. Now, if you have a calculator, which you would on the ACT or the SAT, sure, you could take 64 to the 2 divided by 3, and it'll tell you that it's 16. Or if you're in Desmos, sure, 64, raise it to the 2/3, 16. But you need to be able to do this without a calculator. Here's another one, 27 to the 4/3. The third root of 27 is 3. 3 to the 4th is 81. 3 times 3 times 3 times 3. That's 81. That's how you do it. Next one that Grace sent over. Sheridan sent some more. Let's see. Uh-oh, nothing's coming in. Did you send an attachment, Sheridan? No attachments came through. All right, the next one for Grace is this one. We're solving this for x. What I'm going to do here first is convert this to a fractional exponent. That would be 32 to the 1/3 power is equal to 2x. And our strategy for solving these equations, these exponential equations, at least at this point, before you've learned how to use logarithms, which is going to be the unit after the exponential unit, we're trying to match the bases on either side of the equation. So I recognize that 32 could be rewritten as 2 to a power. I'm going to, and you should know this, right? If you don't know it, do it on your fingers. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. That's 5, right? So I got, this is 2 to the 5th power. 32 is 2 to the 5th. So I replace the 32 with 2 to the 5th, but of course it's still raised to the 1/3 power. That's equal to 2 to the x. When I raise powers to powers, I multiply the exponents. And then we use something in algebra that's called the one-to-one property. It just says that if I get a match right here on these bases, on two sides of an equal sign, the only way that equation could be true is if there's a match between the exponents. So I can just drop the 2's and say, hey, no way, the only way this equation is true is if those two exponents would match. And so then that's my answer, 5/3. The next question is on rational functions right here. We're basically subtracting two fractions. Okay, Sheridan, they came through now. And so you know that if you're going to add or subtract fractions, you've known this since grade school, that you have to get a common denominator between the fractions. And it just so happens that in algebra, the only way to know what your least common denominator is you need to factor everything that can be factored in the denominators. So I need to rewrite each of these denominators in their factored form. So you need to know how to factor quadratics, right? This is going to be x plus 3 times x plus 1. I'm not going to go into how that happens. That's something that you should know, how to factor the quadratic. This kind of factoring is what we would call maybe a special kind of factoring that we taught you in Algebra 2 in the previous units, and that is what we call the difference of two squares. Anytime I have two perfect squares that are subtracted, they are going to factor into the product of two binomials where the square roots of the perfect squares go there, and they each get a separate sign, an opposite sign, plus and minus. So each of those denominators has now been factored. The least common denominator has to include all of the factors that are present between the denominators. So I have to include an x plus 3. I must include an x plus 1. This one has an x plus 3, so I don't need to repeat it. It's already been covered on this one. And this one, here's a new one, x minus 3. I don't look at the x's or the 3's. Those are not factors. The factors of these two denominators are x plus 3 is a factor, x plus 1. Factors are things that are multiplied by the rest of the denominator. So the bottom line is this: the least common denominator is the product of the three unique factors between the two fractions. That means I need to rewrite both of those fractions with this denominator. Well, the first fraction is missing one of the factors. It's missing the x minus 3. So I need to multiply top and bottom by x minus 3. This one's missing the x plus 1. So I have to multiply the top and bottom by x plus 1. All right, let's write this down here. The next step is going to be writing this first fraction with the least common denominator, because I multiplied the bottom by x minus 3, so I get to throw the x minus 3 in with the other two. But then these two have to be multiplied. So now I have x minus 3 times x plus 2. Then there's a minus sign, and then there's another fraction that also needs to have that same denominator. This will be 5x times x plus 1. Well, what I'm going to do, these can now be put over one single denominator because I can now go ahead and subtract the numerators given that the denominators match. I'm going to go ahead and multiply out this product of two binomials. That's going to be x squared minus x minus 6 minus, look what I'm doing here. I got to put this in parentheses because it's minus this whole thing. This will be minus 5x squared plus 5x. I'm just going step by step. X squared minus x minus 6 minus 5x squared minus 5x. My denominator, there it is. Combining like terms on the top. Oh, this is a 5x squared. So this will be a negative 4x squared minus 6x minus 6. There we go. And you would try to simplify this, maybe factor to see if it cancels one of the factors down there. I don't think it does. I could factor out a negative 2. Yeah, plus 3. No, that quadratic there is not going to factor. So there's no simplification to do. And then I would just put that underneath there. Okay, Grace, good questions. Thanks for sending those in. All right, I'm convinced these are ACT questions. I know what these are. So let's take a look. Here is a matrix problem. The matrices A and B are given here. If X is 3A minus 2B, which of the following is X? Well, you don't really need to know what matrices are or what they're used for. We use them, one of the reasons we use them is to solve systems of equations, but matrices are just these groups of numbers that are in between these brackets. But this says X is 3A minus 2B. So that means I need to take 3 times A. So 3A is going to be the product of 3 and all of the elements that are inside. So it's going to be negative 12. I'm going to scrunch this up just a bit and zoom in on that. Okay, so 3A will be negative 12, 0, 6, and 3. I'm going to take 2B. I'm going to distribute 2 through. That's going to be 6, 4, negative 2, and 10. Now I need to subtract them, right? It says 3A minus 2B. So what I do to find 3A minus 2B is I just subtract their corresponding elements. You would probably figure this is what you would do, and it is. You would probably figure distribute the 3, distribute the 2, now subtract the corresponding elements. Negative 12 minus 6, negative 18. I probably don't need to go any further. 8E is going to be my answer. It's got the negative 18. Now, I'll do one more just to check and make sure. 0 minus 4. I'll go with the negative 4. Now I am 99.9% sure that I got it right. That is how you do that problem. Okay, sure. Send me one that's sideways so that we all have to tilt our heads. Okay, let's try it. Let's see. Let's try that again. Okay, everybody tilt your head. No, how about if I rotate it? There we go. In the accompanying, whoops, let's try that again. In the accompanying diagram, segment AB and CD are diameters of the circle. If the length of arc AD is 4 pi, so they're telling me that that distance is 4 pi. What is the total area of the shaded region? Okay, and that is 120 degrees. Therefore, this is total area of the shaded region. Okay. So that means that this would be 60 degrees, which means this is 2 pi in length because the angle is half of that. So the arc length has to be half of that. Would that be right? 60, 60, 60. Yes. Okay. So if that's true, then on this half of the circle, the arc length is 6 pi. Now the total circumference of a circle is 2 pi r. So let's figure, what I'm gonna do here is I'm gonna figure out what the radius is of the circle, knowing that the total circumference has to be 12 pi. How do I know that? Well, because if this is 4 pi, this is 4 pi, and that would be half of 4 pi or 2 pi, and this would be 2 pi. Same, because that's also 60 degrees. So 4, 6, 10, 12, 12 pi. So the radius is 6. The radius of this circle has got to be 6. And they want to know the area of the shaded regions. Well, the area of a complete circle is pi r squared. So therefore, the total area is 36 pi, 6 squared, radius is 6, 6 squared times pi. Well, if this angle is 60 and this angle is 60, and they are, that makes up 120, which is 1/3 of the entire circle's 360 degrees. So I would take 1/3 of this, which is 12 pi. There. There may be another way to do that without finding the radius, but I don't think so. Okay, not the easiest of problems, I will grant you that. And Sheridan, don't tell everybody if I missed that, but no, I'm just kidding. If I missed it, let me know. Another one. All right, I got nothing else on deck, and we still got 15 minutes. This is the last one. Sheridan sent me one other one. In the accompanying, excuse me, diagram, O is the center. The area of the sector is 25 pi. What's the length of arc AB? Well, the sector is 1/4 of the entire circle. So the entire circle is 100, area is 100 pi. And I know that area is pi r squared. So I know that the radius is the square root of 100 or 10. So the total circumference of the circle would be 2 pi r, which would be 20 pi. That's the total circumference, but this arc is 1/4 of that. So that would be 5 pi right there. That's the answer. Macklin, I don't know if you're still with us, but I kind of gave up on that problem because it just didn't work out. And it just seemed like we didn't have the right information on this one. I'm sorry about that, buddy. I thought that the 47 didn't work out right, unless I don't know what I'm doing, but I'm pretty sure I know what I'm doing. All right, students, I'm at the end here. I got 15 minutes and no questions coming in. Well, at this point, we've got 3 weeks left until most of us are going on spring break. I know maybe some of you that aren't in Duval or St. John's, you might have a different spring break schedule, but the bulk of people watching this would be spring breakers in 3 weeks. So make sure that you buckle down these last 3 weeks, because most of a lot of teachers are really scrambling, right, to get done with most of their content before spring break, especially if you're in an AP class, AP pre-calc, AP calc, AP stats. The teachers want to get done by spring break. So this time they start flying through the material. So you got to be really diligent to stay up with things and not get behind. And then if you're in one of those AP math classes after spring break, things are a little bit more relaxed, because then you've got this month, you're going to have actually more than a month to prepare for those AP exams in May. So then you get to go back and you'll review the content. You will then do lots of practice problems. Your teacher will probably do more focus on using your calculator on the calculator portions of the exam. And so a lot of you haven't used your calculator maybe to the full extent that you need to in your AP math class, but those holes are going to get filled in between spring break and when you take your exam in May. So don't get complacent here. All right, now's not the time to give up or to go soft in your math class. I tell my math students that I coach on a weekly basis, I tell them you've got to be doing math every day. Right? Okay, maybe at least 5 days a week, but I really every day, 15 minutes a day. And if you are in a unit that has maybe 7 types of problems, every day you should just do one problem of each type that you've learned. Like in exponentials, for example, do a graphing problem a day, solve an exponential equation each day, do a compound interest problem per day. Just stay fresh on all of the concepts for the unit for your next summative. Right? So you can't let things go cold from the very first part of the unit. Stay up with it. That is my best advice to you. Let's see if anything else came in. I don't see so. It looks like I'm drawing a blank here on my inbox. So what we're going to do is we are going to end it a little bit short tonight, students. I will be back here again next Sunday night at 8 p.m. You can send me stuff to askmrrich@gmail.com anytime during the week and say, hey, this is for Mr. Rich Q&A. Just send it to the email, even if you're sitting in class. Of course, maybe you can't get your phone out in class, but at lunch, you could get your phone out and take pictures of homework problems that you think you need help with and send them to my inbox, and then I'll pull them up and put them first in the queue on my next Sunday night at 8 p.m. All right, everybody, have a great week ahead. Those of you who are taking the ACT on Tuesday, good luck. Get a good night's sleep before, and look forward to hearing some good scores from all of you. I will see you next time. Thanks, Sheridan. See you later.